to make sure it's clean on the where we're going to hold it in the chuck. We're going to just snug the jaws up and then tap it in with the hammer. Make sure it's tight against the up to the shoulder of the jaws here. Okay. Snug it up just a little bit more. I'm going to bring the spindle down, put the dial indicator indicate the part in on the chuck, right here on this turned area that's right in front of the jaws. It's the reason I kind of turned it back that far from the first operation. I had to tip it at this angle because it's going to hit the jaws up here. But this is just a it's just kind of a reference comparison from one side to the other, so it's not really that it needs to be you know, you get some error running the indicator like this, but it's not going to be significant for what we just want check run out here. Up tight against the back of the step in the jaws. Check it one more time. Thinking that looks pretty good. Now, I've already set my 0 to control the part length, so I don't need to really do that. Here's the first tool, which is going to be the same as the roughing tool before, but I oriented it this way because I want to make this facing cut, and it comes down too far in X. The chuck jaws would hit the base of the spindle if it's oriented the other way on the previous setup. But it's the same tool. CNMG 432 insert, 400 surface footage, 12,000 speed per revolution. To rough the OD. We're going to bring the Sandvik silent bar next to rough the ID. Same feed and speed as the OD roughing. But the depth of cut I think is only 100 thousandths. On the OD we're doing 1/8 of an inch per pass. The finish OD tool. Do 2 facing cuts on the shoulders first, and then a finish cut down the whole OD. That seems to work good with the diamond insert. Will get push off on the faces if you don't cut them first. Measure the OD. I want this to run a little bit big because I want the threading insert to top that OD on, so I can kind of measure with a full profile Acme threading insert I can measure the thread that way. This is the finish ID tool. Do a 1 pass, and sometimes there's shavings in there I have to clear out, and then do a spring pass. Those silent bars have a little bit of flex to them, and you have to do that with them. So that looks pretty good there. Not a close tolerance, plus or minus 5 on that, and on this depth. come in with the threading tool, a 12 pitch stub acme thread. So generally run this, I set the offset out a little bit and run it. And because I left that OD a little bit big, I can measure it with the mic and get an idea, and also measure the depth here with this depth gauge. And I can pretty much get an idea where I am with this acme thread just by doing that. If I take the OD down until the insert tops and take it down in between the maximum and minimum OD size, I can kind of be sure that it's the right size as long as the insert's in good shape. So I'm rerunning the thread here because the OD was just a little bigger than I wanted. I mic it again. And when I get where I think I'm good, come in here with the thread wires and measure the pitch diameter with the thread wires. So everything seemed to look alright there. So then I'm going to run the blunt start, which is I'm going to mill it on here with a 1/4 inch end mill. And this is just basically a helix going straight in, and Z, the pitch of the thread, and then a little line tangent to that coming straight out to make the blunt start. When you get to the full lead width, I guess you might call it, and you only have to do 1 revolution to do that. To me, that's easier than trying to turn it with a grooving tool. So that's this operation. Thanks for watching.